All right, you're welcome to this class again. We'll be taking magnetic field at this point in time. All right, we took electric field the other time, and now we are looking at magnetic field. Magnetic field. Okay. And once you are dealing with magnetic field, then force comes into your mind. That is the force that is found in that environment of your magnetic material. Take, for example, this is a magnet. The magnet will always have an attraction effect, okay, around it. Okay, let's take, for example, the strength of this magnet can only be between this environment here. That's just the environment I've given to you. That tells you that the force of attraction will only be from here to here. That tells you you have gotten to what? To the limit of that field. Okay? The environment where the magnetic effect can be felt is what we know as what? The magnetic field. Okay. And since that's the case, we know that there is a magnetic force. We have the magnetic force. And it's given as QVB sine theta. All right. QVB sine theta, that is the product of the what? The charge, the velocity, the what? The magnetic flux, and then the angle between the what? The velocity and that of the what? The magnetic field. All right, that's the B there. Okay, so this is the expression for the magnetic force. Be mindful of your V and B. Very interesting. Okay, if these two act parallel to each other, then here becomes what? Zero. The force will become zero. Okay, parallel to each other. That tells you that your angle will become zero, and it in turn affects the whole product, resulting to zero force. But if you have it perpendicular, if this acts perpendicular to each other, that's the V and the B, that tells you that the angle is at what? 90 degrees. So the value here will be equal to 1. Some situation when you have this angle given as 90, you might not need to what? Solve any problem. You already know that your F will be maximum. Okay, that's the maximum value that you have. So for this, F will be equal to 0, but for this case, F will be maximum. All right? If the question says, at what point will you have the maximum magnetic force? At that point, your angle here will be 90 degrees. All right. So, another expression to determine the magnetic force is that the force F on a conductor of a length L, okay, assuming we have a conductor, the force on it, maybe let's assume that the conductor is carrying current at this point in time. All right, we are going to have the current, the length of the conductor, and the magnetic field, which is this, at work. And at that point in time, we said F will be equal to what? BIL sine theta. Compare the expression. At that point in time, we are not interested in the charge. Okay, the magnetic field, the current, and the length of the conductor. That's all. Okay, find the product, sine theta. This same condition happens here. It relates to this work here. That is, when what? The B and I, we are comparing B and I now. Okay, when B and I are parallel, then you have what? F to be 0 again. And when you have B and I to be at what? 90 degrees, you will have F maximum. Let's take note of that. Then we take some questions. Let me give us the last expression for this magnetic field before we will take a question. Okay? The ratio of force to the length is directly proportional to the reciprocal of the current. This is what we have. Okay? The ratio of force to length is inversely proportional to the current. Okay? If we cross multiply, what do we have? We can have it as Fi directly proportional to what? To the length. This is very much valid. We can make use of it to solve problems. We're going to have a question that will relate the force and the current. Okay? Let's take 2 questions under this magnetic field to analyze the formulas that we have on the board already. Take note, Your magnetic force is QVB. This is what? Quantity of charge. This is velocity. This is magnetic field. Please take note. Magnetic field is measured in Tesla. That's the unit of magnetic field, or Weber per meter square. All right? And then you know your angle is always in degrees. Charge is in coulomb. Your velocity is meter per second. All right. And the value here, this is the same thing as this. Tesla or Weber per meter square. Your current is in ampere. Your length is always in meters. That settles it. All right, let's take question 1. Question 1 goes thus. A proton moving with a speed of 1 by 10 to the power 6 meter per second through a magnetic field of 1T. What does the T stand for? You remember that is Tesla. Experiences a magnetic force of magnitude 8 by 10 raised to the power of minus 14 newtons. The question is, calculate the angle between the protons, velocity and the field. This, okay, the proton charge, take note of this. Proton charge, which is that Q, is 1.6 by 10 raised to the power of minus 19 coulomb. All right? This is JAMB 2005. Number 6. You can confirm that. Let's go through the question, then we solve right away. A proton moving with a speed of 1 times 10 raised to the power 6 meter per second, that gives you your what? Your velocity. Through a magnetic field of 1 Tesla, that is your magnetic field, and this is your velocity, experiences a magnetic force of magnitude 8 times 10 raised to the power minus 14 newtons. The question here is to calculate the angle between the proton's velocity and the what? The field. We are looking for what? The angle, which is the theta. Okay? So from our expression, we said what? F equal to what? QVB sine theta. This is our problem now. So let's make theta the subject of formula. We divide through by QVB, here by QVB. Okay? Don't forget, all these I've done in a very split of seconds because of your time. This takes care of this. You have what? Sine theta equal to what? F over QVB. Okay, because of time constraint, what do? You go straight. Find the what? Sine inverse of this value. So your theta right away will be what? Sine inverse of what? What is your force? You trace it. Your force is here. 8 by 10 raised to the power of minus 14. Everything over what? The Q, which is the quantity of what? Charge. Let's move through. Your quantity of charge is, okay, we have it here, proton's charge. Okay, that's 1.6. 1.6 by 10 raised to the power of minus 19. Multiplied by what is your velocity? Your velocity is right here. 1 by 10 raised to the power of 6. Then the next information is your what? Magnetic field, which is the 1 Tesla. You multiply by 1. You just divide this by this, then find the what? Sine inverse with your calculator, and then you arrive at 30 degrees. Your theta is 30 degrees. So we'll be taking the next question to analyze this magnetic field, and it goes thus. The question is 2007, number 38. All right. Number 2. It said 2 long parallel wires. This question is very technical but very simple. 2 long parallel wires, X and Y, carry current 3 ampere and 5 ampere respectively. What does that tell you? That is 3 ampere for X, 5 ampere for Y. Now, if the force experienced per unit by X is 5 times 10 raised to the power of minus 5 newtons. The question is to calculate the force experienced by Y. All right, very simple, but quite technical. Okay, we are given 2 wires. One is X, the other one is Y. This one carries a current of what? 3 ampere, and then the other carries the what? A current of 5 ampere. Now we have been given the force per unit area to be 5 for X, to be 5 by 10 raised to the power of minus 5 newtons. So we are to determine the what? The force experienced by Y. You remember that we have force per length is directly proportional to what? It's inversely proportional to the current. So from here, from our analysis, we said what? Fi is directly proportional to the what? Length. We are not concerned about the length, we are concerned about this. And we are comparing 2 items. So we can now have Fx, let's call that, and then Ix will now be equal to the other what? Wire, which is what? Fy, Iy. With this, you have settled the problem. And that's all. So let's punch in the value, and then we see what we have. What is the force of X? It's given as 5 times 10 raised to the power minus 5. That is 5 by 10 raised to the power of minus 5. What is the current? Okay? The current is given for X is 3. For Y, it's 5. So we multiply this by 3. Equal to the force experienced by Y is what we are after. So we leave it as what? Fy. And then the current by Y is what? 5. Don't forget, X and Y is given as 3 and 5 respectively. So the corresponding value for Y is 5. So we multiply this by 5, and that is 5 Fy equal to what you still have here, your value. So calculator will what? Flush it out once. You divide through by 5, and then Fy jumps out. So my Fy will be equal to 5 times 10 raised to the power of minus 5 multiplied by 3, all divided by 5. And that settles it. Your final answer should be equal to 3 times 10 raised to the power of minus 5 newtons. This is the force that will be experienced by the second wire Y. This question is number 38, 2007. 2007 question 38. With this analysis, then you will not have problem relating one, product of force and current to the other. It can be involve 3 or more materials, but that's 2 or more. We have just 2 here, and then we have gotten the value for the force experienced by Y. I hope you've learned a lot from here. Any question you have here can always be related to the information given to you. That is, the magnetic force equal to QVB. Your Q is the quantity of charge, your V is your velocity, and the B is your what? The magnetic what? Flux, and it's measured in Tesla or Weber per meter square. Don't forget you multiply it by the what? The sine of the angle. So when the 2 items are parallel, you what? Have F as 0, because automatically the angle will be what? 180 or 0. Multiplying through, what am I talking about? From your F equal to QVB sine theta. Once theta is 0 or 180, parallel flow tells you that the angle is 180 or 0. it affects the whole product, and then it results to f being equal to what? 0. If you are given such question, you don't need to punch your calculator. All you need to do is to what? Pick your answer as what? 0, in as much as the two happens to be what? Parallel. Okay? And the second one says if they are perpendicular, this young man here becomes what? 90 degrees. Okay? And you have the maximum value for your force. And the second one, F equal to what? BIL sine theta. Same thing happens here. Once your what? Your magnetic flux is what? Parallel to that of the current, then you have it as 0. The whole thing here becomes 0. Your force will become 0. You have to be time conscious. You have to add up with your speed. Speed and accuracy is the code, and that's all. You can always be at your best. Thank you for staying tuned. Wishing you all the best. Okay? You can always be the best. I wish you all the best in your examination, in your UTME exams. Speed and accuracy is the code. Just give it to me, punch the calculator, and that's all for physics. You can make 100%. Thank you so much.